Hey, this video is just to highlight some of the thinking that I was promoting in regards to angle measurement. There still seems to be some misunderstandings about what it means to measure an angle. So first of all, here is an angle. This is two rays connected with a common endpoint. We call that common endpoint the vertex. And we might want to measure this thing we call an angle. Well, first of all, whenever we talk about measurement, we have to ask the question, well, what about that thing that you call an angle, or whatever the thing is, what about that thing do we want to measure? I say, what attribute or what characteristic about an angle do we want to measure? So for example, we might say, not correctly, but we might say, well, we want to measure the length from here to here on this angle. We might want to measure the length from here to here. We might want to measure just the straight line distance from here to here on that angle. Well, that would be something to measure, an attribute certainly to measure on that angle. But is that really what we mean when we say we're going to measure an angle? No, it's not. So we want to be very clear. What attribute or what characteristic about this angle are we trying to measure? Well, the truth is, when we measure an angle, what we're measuring is not this idea of space inside. The space inside is really vague. I mean, how much space is inside of here? Well, where are you going to stop measuring that space? And if we promote this idea with our students of measuring space inside, then can you imagine that we have that same angle, but we make it a little smaller, like you saw in the Canvas conversation? A student could easily mistakenly say, well, there's less space inside this angle than inside this angle, and so this angle is bigger than this angle. And that is not the kind of thinking we want to promote. So we need to be very explicit and clear. What attribute, what characteristic, what is it about this angle that you want to measure? And here it is. What we want to measure about an angle is this. Imagine drawing a circle on top of this angle such that the vertex of the angle is the center of the circle. So I'm going to do my best freehand drawing of a circle. Pretend, if you would please, that that is a perfectly drawn circle centered at the vertex of that angle. When we talk about measuring an angle, what we're talking about is the length of that arc right there. The length of the arc associated with the circle that we've drawn in the way that we've drawn it. So, number one, about measurement. What attribute do we want to measure? We want to measure the length of that arc. I don't know if you can tell, but it's in purple. How big in length is that purple arc? Number two, find something else that has the attribute of length. Well, there's lots of things that have attributes of length. We could measure that arc length in terms of inches or centimeters or something like that. But as you've seen, a really convenient tool for measuring the length of that arc is to use the radius of the associated angle. So the radius, I'm sorry, not the associated angle, the associated circle. The circle has a radius length of about that much. So what I'm going to do is I'm going to use this as my measuring stick, if you will, and I'm going to measure that arc length. So number one, what attribute do you want to measure? The length of that arc. Number two, choose something else that has the attribute of length. This does. Number three, compare multiplicatively. What that means is, how many copies of this will it take to span that arc length? Let's do it. There is about one to there, and then maybe another. It was one and maybe another about that much. So which we call it about, I call it a third. So about 1 1/3 radius lengths is the length of that purple arc. 1 1/3 radius lengths. Now, that's what we do. Choose the attribute you want to measure. Not the space inside, but the length of that arc. Number two, find something else that has length. Radius. Number three, compare multiplicatively. indicatively. How many copies of that radius does it take? Okay, now, if you're doing this in a classroom with students, a student might wonder, okay, fine, I get that, but what if you made the circle a different size? Wouldn't you get a different answer for the length of the arc? So for instance, what if a student said, I'm going to measure this arc instead? So again, we're going to draw a circle centered at the vertex of the angle, like so. Pretend again that that larger circle is a perfect circle centered at the vertex. And the question again would be then, what is the length of that arc right there? Now at first glance, a student might say clearly that second arc is longer than that first arc. So the angle could not have the same measure. But the question is, what are we going to use to measure that second arc? We're not going to use the first circle's radius, we're going to use the second circle's radius. We're going to measure the length of an arc using the corresponding circle's radius as our measuring stick. So now, look at that, I did that just perfect. I couldn't even plan that better. So the radius of my angle, of my circle, is exactly the length of this wiki stick, as we call these. So I want to measure that arc length in terms of this wiki stick. So let's do it. How many copies of? So there's one for sure, and then about that much more, about that much more. And that much more again is about a third. If I ballpark it, it's about a third. Yeah, I'm going to call that a third. So this also is 1 1/3 radius lengths, but 1 1/3 of these radius lengths. This smaller one is 1 1/3 of these radius lengths. And if we made a, say, a circle like in here, that arc right there would have 1 1/3 of those radius lengths. It's proportional. That's the whole point. There's a proportionality here. Beautiful thing. So that's what we're doing when we measure angles, is we're trying to determine the length of that arc that's associated with the circle that is sort of spanned by that angle. Now, just to be super clear, not every angle is going to have the same measure. Can you imagine an angle like this? That angle is not going to have the same measure as the first angle that I've drawn. So here's what we would do. Using the vertex as the center, we would draw a circle. That one was really bad. Can you use your imagination, please? What we're measuring now is the length of that arc. And what we're going to use to measure the length of that arc is the length of the associated radius of the circle. So how many copies of these radius lengths are in that arc length there? Well, it's not even going to be 1. It's going to be about that much. So there was 1 full radius length. We're talking about just that right there. So what is that? Maybe it's a quarter. So that angle would be about a quarter of a radius length. Now I know in your posts and because of your experiences, you have this idea that anytime we talk about angles, we have to talk about degrees. And that's just not true. Not every angle needs to be measured in degrees. That is one way we can measure angles, but also this idea of radius length can also be used. In fact, in calculus, we prefer radius lengths. Measuring angles in radius lengths is a much more convenient way, much more precise way to do what we do in calculus. And so I don't want you to get off on this idea that we always have to have degrees. Now we could convert all of this to degrees. Do you remember that day where we measured the circumference of a circle based on the radius of that circle? We would say it was 1 radius length, 2 radius lengths, 3 radius lengths, 4, 5, it was like 6 and a little bit more. In fact, the circumference was about 2 pi, what was exactly? 2 pi radius lengths. So what we could say then is this. If 2 pi radius length spans a complete circle, well then, we know from the ancient Babylonians, they took a circle and divided it up into 360 little arc lengths. So 2 pi radius lengths is the same as 360 little degree lengths. So half of 2 pi is 1 pi. Half of 360 is 180. For example, if you had pi radius length, we could say, well, it's 180 degrees. Half of that would be 90 degrees. Half of that would be 45 degrees, and etc. You could do whatever you want. You could say a third of a pi would be about 30 degrees. You know, you can go on and on and on and on. So you could convert your radius lengths into degrees if you wanted to, but I don't even want to go there. I want us to focus on the idea of measurement here. What are you doing when you measure an angle? You're measuring the attribute, specifically, we're measuring that arc length using a radius length as our measuring tool, comparing multiplicatively. That's it.